Okay? So, here's the deal, you guys. It will likely on the actual test, I will probably put at least one of the problems 1 to 4. Okay? Those were the ones that were true out of an AP prep book kind of problems. Okay? The rest of them are kind of multiple choice that kind of match your textbook. All right? Unfortunately for this section, it's important for us to learn, but there's not a whole lot out there on AP tests on it. It's like a question or two. Okay? All right. So here's the thing with this one. We have to do a U-substitution before we can do the integration by parts. Okay? So I'm not going to use a U, I'm going to use an A. All right? Oh, let me grab. Sorry, I'm not on a pen yet. Not on a highlighter, not on a. There we go. Okay. So I'm going to say that A equals x squared. So what does that mean that dA equals?
2x dx.
Now, looking at this, I'm going to rewrite it. I have x squared e to the x squared x dx. Do you see what I did?
Yeah.
I pulled out the x, correct. So do you see how that's right here? So I'm going to get to replace that piece. I'm going to move the 2 over to the other side by making it 1/2. Okay, so now we're going to use our U-substitution in, and then we're going to do our integration by parts. So for the, anytime I see the x squared, I'm going to put in a. So e, or a, e to the a. And then for the x dx, I put in the 1/2 dA.
Whoa. Wait, how come it's not x dx?
What do you mean, how come it's not x dx?
Oh, wait, never mind.
Because I replaced, right? Okay, so now I'm going to do my U-substitution. So for my U, if we used our LIATE, right? It would be algebraic, wouldn't it? What's my algebraic piece?
A.
The A, so that means the derivative is dA. Oh, this is how I got it done. I'm not sure what else you would have done with it. All right, so dV equals the e to the a dA. So when I integrate e to the a, what do we get? E to the a. All right, so now we're going to do our integration by parts on it. So I have a 1/2 that's just going to hang out in front. My u is what? A. My v is e to the a minus the integral. My v is e to the a. My du is dA. All right, so I have a 1/2 hanging out. I've got a, e, a. When I integrate e to the a, what do we get?
E to the a.
E to the a, and then plus c. So do you see how I have a greatest common factor hanging out in there?
Yeah.
Technically, I'm going to pull that c out of the parentheses. It really doesn't have to be in there. I'm going to pull an e to the a out, and I'm left behind with a minus 1, and then I have to replace a with x squared. So e to the x squared minus 1 plus c.
Whoa. You're so smart with that.
Thanks. All right, we good with one?
I just had to do weird factoring.
You had to do weirder factoring than that?
So it's a.
Okay. So that was cleaner, is what you're saying? Probably. All right, are we good now? I can keep going?
So when it has an odd exponent, we have to rate it.
That kind of, it was basically, I wasn't able to do a U-sub, right? A traditional U-sub. So, and I wouldn't have been able to integrate this piece here nicely, right, with integration by parts. So I had to figure out how to deal with that.
Oh.
So that's where, and we hadn't seen one like that, I don't think, anywhere where we had to do a U-sub and then do a integration by parts. Okay?
It took me a little while to figure out how to integrate that.
Yeah, so this was probably quicker. All right, let's look at this one. This one is another integration by parts, even though it doesn't look like it. Okay? Whenever you have an inverse trig, you can think of it as arc sine x times like a 1 in front, right? Or just times the dx, all right? Because you can integrate the dx part. All right, so when we decide on our u, what would we use as our u in this case? Yep, u equals arc sine x. So du equals, you need to know this derivative.
Cosine. Negative
Nope.
cosine.
It's like 1 minus something.
1 over,
You're way off.
The square root of
Yep.
1 minus x squared.
good, dx. Alright, and then that means dv, so I the arc sine, right? Where is the dv? Dx, so that means v is x. Alright, so now we're going to do our uv. So u is arc sine x, the v is x. Right, I'm doing u, it was uv. I did it backwards. Minus v du. So v is x, du is the 1 over the square root of 1 minus x squared dx.
That's a trig.
Actually, we don't need to do trig. We don't need to do the trig substitution because I can do a U-Substitution.
Yeah.
Okay. All right. Is it going to freak you out if I use another U, or do you want to use a different letter?
Just use C for Cody.
C for Cody. Okay. So we're going to do a C substitution. And I know to do that because if I look at what's here, when I take the derivative of x squared, doesn't it appear?
Yeah.
That's how I know I'm doing the old U substitution. So I'm going to do 1 minus x squared for my C. So dc is what?
2x.
Good. And what I'm missing is the negative 2. So I've got negative 1/2 dc.
Is that dx or dy?
It's a dx. And then x dx. We've got x arc sine x minus, I'm going to do my substitution now. What am I putting in for the 1 minus x squared?
1 over dc, negative 1/2 dc.
I get c, and it's to the 1/2 power. To bring it upstairs, we make it negative. Okay. Are we okay with the c replacement? I put c in for this. It's to the 1/2 power because of the square root, and I brought it upstairs. All in one step. Okay? For the x dx, I am putting in negative 1/2 dc. So negative 1/2 dc. What happens with my double negative?
It goes positive.
Positive. So we've got x arc sine x, which we better. Look at all those first parts of those. We have to have that, don't we? All right. Plus 1/2. When I integrate c to the 1/2, I get c to the what? Or c to the negative 1/2, I get
1/2.
c to the 1/2, and then plus, divided by 1/2 or multiplied by 2, plus c. And then instead of writing c, I'm going to write 1 minus x squared. What's going to happen?
Cancel.
Got to cancel the 2's. So we've got x arc sine x plus the square root of 1 minus x squared plus c. So it should have been answer choice B, it looks like. All right, are we good with 2? Okay, I'm waiting.
Is D. I didn't see that. Nice, bro.
All right, we good with 2? All right, so number 3, you're not going to like this. Okay? It's kind of set up like a integration by parts, right? But before we do integration by parts, let's see if a U-substitution would work. All right? So, what do you think you'd pick for U?
X squared.
X squared, good. So du equals what? 2x dx. Do you see the x dx in there? Yeah. All right. So I didn't need to do integration by parts. I can do it with a regular U substitution, which is much easier and preferred, right?
How do you know when you can do it?
What?
How do you know when you can do it?
You can do it. Always try the U substitution first. Basically, we've given you a whole bunch of tools to integrate, right? You've got to decide what to do when, and you can always start with something. If it doesn't work, try something else. Okay?
Use substitution or it wouldn't work?
It won't work sometimes. Okay, that's why we have the other methods, right?
Well, how would you know it wouldn't work? You can't solve
Yeah, if you can't get the u, if you can't see, if your u doesn't appear, then it, or your du doesn't appear in there, then or if you end up having to move an x over here to try to, it does. You need to try something else. Okay. All right. So we've got cosine u, and then for the x dx, I'm putting in 1/2 du. All right. When we integrate cosine, what are we going to get? We integrate cosine, we get positive sine, and then for the u, instead of writing u, I'm going to write x squared plus c.
What?
Yeah, it was pretty easy, wasn't it?
Man.
Is that the one you want on the test?
Yes, please.
Yes, please. Joaquin votes for 3.
Yes.
Yes? That was on probably last year's test on integration. All right. What's wrong, Alexis?
What about that X in front of the sign?
Oh, there's an X in front of the sign. What happened? I don't know.
Hey, we still got it right.
Forget about it.
No, something went wrong.
Yeah.
Maybe it's possible I typed something wrong. It might be that. I don't know what happened there. So, I'm going to go for I typed something wrong. Because it works with the U-Substitution without it, doesn't it?
Yeah.
We'll make sure that the X isn't there. It probably shouldn't have been there. Okay? Alright. Let's keep going. Alright, let's look at this one. This is another good one. This one is a definite integral, one of the few definite integrals that was in here. Okay? We are going to have to use integration by parts. Okay? So, knowing what we know about integration by parts, you guys are listening. What do you think we should use for our u? Yep, natural log x squared. So du, what's the derivative of the natural log of x squared?
2 over x.
1 over x squared, and then the chain rule gives us what? 2x.
2 over x.
So that reduces to 2 over x dx. I'm miswriting the dx. Okay. So that means that dv is what? X squared dx. When I integrate dv, I get v. When I integrate x squared, we get? Good. All right, uv. So u is the natural log of x squared. V is x cubed over 3 minus the integral of v du, which is 2 over x dx. All right. This is I'm going to simplify this before I try to integrate. It's going to go to squared, right? Natural log of x squared minus, and I've got a 2/3 left, x squared dx.
It's the limits.
Oh, I'm ignoring the limits for a minute.
Do you have to change it up?
I'm not going to. Because it's a v and it's a uv, right?
Yeah.
And technically we're still in x's, aren't we? So we don't have to change the limits.
So you never.
I'm just going to wait till the end and put them back in. Okay? You just can't, well, obviously you wouldn't forget to do it. It's multiple choice, right? All right, x squared. When I integrate x squared, what do we get? Yep, 2/3 x cubed over 3, and that it was a definite integral, so I'm going to put my limits back on 1 to e squared.
I thought you had to plug it, find your limits.
No, I don't, because it's all still in x's, right? So I don't need to convert.
And then would you plug it into the entire thing?
U-Substitution.
Yes, you plug it into the whole thing.
Okay.
Yeah.
What does it change to x squared to x?
Because I was integrating it, so I have to add 1 and divide by the new exponent.
For the natural log of it.
Oh, what happened? Because for in here, oh, it shouldn't have. Thank you. Right there. Okay, let's put in our e and our 1. So I'm going to start by putting in my e. So what's e squared cubed?
E to the 6th.
E to the 6th. You multiply your exponents over 3. Natural log of e squared squared would be e to the
Quattro. How did you get
fourth.
E?
How did I get e?
It's the
I'm
limit.
plugging it in.
Oh.
Okay. All right. Minus, and this is really 2/9, right? So I'm going to go with 2/9. And then e squared cubed again would be e to the sixth again. Minus and put a parentheses. So now we're putting in 1. So 1 cubed is 1. So I have 1/3 natural log of 1 squared minus 2/9 times 1, or times 1 basically, right? All right, what is the natural log of 1?
0.
Always 0. So that term just got wiped out,
The whole term?
the whole term. So I have a minus 2/9 here at the back.
Plus 2.
Oh, double negative, you're right. It's a negative times that negative, so it goes positive. All right, here, what happens with the natural log and the e?
They
Cancel.
cancel.
They cancel, so I really have 4e to the 6th over 3 minus 2e to the 6th over 9. So here's where it gets tricky for trying to get a common, we got to get a common denominator, right? What do I have to multiply the 4 by to get, or the 3 by to get a 9?
3.
So I need to multiply this by 3. So that gives me 12e to the 6th over 9 minus 2e to the 6th over 9 plus 2/9. So what's 12e to the 6th minus 2e to the 6th? 10e to the 6th
I don't know where that.
plus 2 over 9. Sorry, I wrote out of space. I'll write it normal.
Same.
10e to the 6th plus 2 over 9.
Wait, 10 to the 6.
Mm-hmm. Because you had e to 12 minus 2 is 10.
That's over 9.
Over 9, yeah. Everything's over 9.
Oh, you said over 6.
Oh, did I say? I said to the 6th.
Oh. I don't even know.
All right, we good?
For my brain.
All right. Do you want me to do number 5, or do you want me to keep moving? Yes, you want me to do number 5? Okay. So, technically you need a U-Substitution, but what does my U come out to be? Or my DU comes out to be, so do I really need a U-Substitution?
No.
Not really. Okay. What? You want me to put that one on the test too?
Yeah.
Maybe, we'll see. That's why I was asking if you really needed me to do it. All right, so 2 at x minus 2, I have to increase this exponent by 1, so what do I get?
8.
8 divided by my new exponent plus c. So x minus 2 to the 8th plus c. So it should be this one.
Hey, can you do it again?
Yeah, because I.
Really?
That was too simple.
It was too simple?
Yeah, because I knew that.
All right, so I took this thing. I didn't end up needing the U-Substitution because it just came out to be a dx. So I literally took that as a whole term. I added 1 to this exponent, and I divided by my new exponent.
How would you know how to do that?
When to do that? That's what we always do.
I was like, wait, you still gonna be in.
Yes, that's the very first part of integration. I looked at my u first though, didn't I, Joaquin?
Yeah.
And I realized and I could do it with the u. We can do it with the u. 8u to the 7th, and then so you do 8u to the 8th divided by 8,
Let's do the same thing.
and yeah, it is. So that's why we're in BC. I'm not going to do that extra step. Okay. All right, we good with 5? All right, like 3 of those on the test. No, you'll be lucky if there's 1.
Just have that be the whole test.
All right, none of 6.
Yeah, I could not figure it out.
You'll be guaranteed to have 1 like 6.
Oh.
Okay, so make sure you know how to do it. When all else fails, long division.
Oh, mom is.
I want to see that you can do one by this, so you're going to see there will be 1 long division on I won't do more than 1, but there'll be one. That doesn't mean skip it. Okay, there'll be 1 long division on the test. Okay? All right, how many times does t go into t squared? T times. So t times t squared. T times -5 is?
What? 5 t.
Negative 5t. Remember, I'm distributing that. Okay? What do we do to the signs? Change them. So the t squareds go away. 0t plus 5t is 5t. How many times does t go into 5? 5. Good. And then I'm going to distribute again. So 5 times t is 5t. 5 times negative 5 is negative 25. And what do we have to do to the signs? Switch them. So I'm left with a remainder of 25. So it's plus 25 over whatever we divided by. Now I am able to integrate that. Yes.
So is it always just is it always just how t goes into it, or like the?
Yes. Okay. However, always check this into that first one, and then everything else falls out of it. Okay. Yeah. Okay. How do I know when to use long division? First of all, I try to use sub nothing, and it didn't work, right? So, because if I did the u on the t squared, I have du would be 2t, and this t is in the denominator, right? It have to be in the numerator. So my u sub didn't work. My other clue is looking at my answer choices. There's natural logs in them. Okay, so I have to be able to get that natural log. So, and I can't have and my u sub for the natural log isn't working out here. For natural log, I'd have to use the u would have to be t minus 5, and that doesn't work. Okay. So, when all else was, and the other thing is look at the exponent in the numerator is bigger than the exponent in the denominator. That's another clue to making sure you're doing that. Okay, so I'm going to come down here and integrate this. When I integrate t, what do we get? T squared divided by 2. Plus, when I integrate 5, what do I get? 5t. And then I integrate, 25 is just going to hang out. 1 over something is always what? Of the absolute value of t minus 5 plus c. They're saying it's answer choice A.
Why'd you make the 25 just hang out?
Because it's a coefficient. It's the same thing as, this is the same thing as saying 25 times 1 over t minus 5.
Yeah, I got you.
Okay? Alright, we go with 6? Alright, let's keep going. I'm waiting. I'm waiting. We good? Okay. Number 7. Find the definite integral. So before I try to do a trig sub, okay, I would try to see if it fit one of my arc integrals first. Okay? Or if a U-substitution works. Let's try the U-substitution and see what happens. What would you assume your u would be? Okay, so let's see what happens with that. So du equals what? Ooh, so will a u sub work? We have an x dx, right? It's not a big deal to move the number over. So 1/2 du equals x dx. So let's do a u sub. Okay. So I'm going to carefully do that u substitution. For the x squared plus 225 I'm putting in. 7 is going to be outside, yeah. And I'm going to put in u to the 1/2 for the radical, and then to the negative to bring it upstairs. For the x dx, I am putting in 1/2 du. All right, I am going to change the limits because I'm not plugging back into that. So.
Sorry I'm late. What are we doing?
What are we doing? Well, we're trying to review for a test. You're being very disruptive.
Oh, but I'm not. Oh, you know what? I just thought about this. My mom, she told me to get my grades because she said it was kind of down here in Calc. So, can I get my grades too?
Can you get your grades? We can look in Aries. That's where I post them.
But she wants it to be signed. Like, it needs to be signed.
It needs to be signed. Did you bring a pen or paper to class?
No, I can get one. Can I get this? Thank you. Can you?
I can't do it right now. You can come back during your lunchtime or passing period.
It's like, I didn't know.
I can't do it right now. You have to come back on your own time because you're being disruptful to class.
Fine. Can I get the notes then? Oh, I forgot this. Can I get this too?
No, you have to bring your one from home.
Why don't you have a shoe on?
The good
Okay,
news is
guys.
I'm videoing this lesson, so you can watch it later.
Hey, listen up. 5 behavior expectations here at Toggles. The poster's up there. Which ones did Miss Mallory just break?
Come in here, rude.
Be respectful. She wasn't very respectful, was she? Disrupted the whole class, correct?
Not really.
Yeah.
What else?
Be prepared.
Was she prepared?
No.
Nope, she didn't have anything, did she? What else?
Not on time.
We were definitely not on time, were we? You guys have been in class for how long now?
I don't know, the bell rang a while ago.
It's been quite some time, yes. What about responsible? Was she responsible?
No.
When should she ask Ms. Ballard those questions? On her own time, exactly. What about make good choices? No, she didn't make any, did she?
No, she did not.
Okay, the reason that we're doing this today was so that you guys could see how it is when when students disrupt the class. So you see if you do it, that's how you look to the whole class. Not quite as bad. Miss Mallory took it a little over the top, but maybe not for some kids. I've had kids act like that before too. But just to show all the teachers that it's pretty simple. We took 2 minutes of your time, and thank you. We appreciate it. Have a good weekend.
You too.
All right, back to calculus. All right.
Wait, that was an act?
Yeah, you didn't get that? It was a performance. Did you not know she was a teacher? That's good. I'm gonna tell her you guys thought she was a student. She'll like that. Oh, to do the model lesson? Yeah. Okay, here we go. They did it on purpose, okay? So, all right. So you might see the act later today. They're doing every building at some point during the day. Okay. So we're gonna integrate this. We've got 7 halves. Oh, I forgot. I didn't change my limits, right? I was gonna do that. When we put in 0 into this, what do we get out of it?
Hold on. In where?
Into the U. 255. Okay. Because I'm not going to put my U back in. So, and then when I put in 8, so 8 squared is 64. What's 64 plus 255?
315. I lied. I don't know what it is.
Did I lose? I'm sorry. I wrote it wrong. You're right. It's 225, not 255. Thank you. You were right. I was wrong. I wrote it wrong. That was Miss Mallory's fault. All right. See, I'm passing the blame. Okay.
I didn't say anything.
So, what are we, when I put the 64 plus 225 in, what do we end up with?
280.
289, good. All right, so we're going to integrate the u to the 1/2. All right, so when we integrate u to the 1/2, I'm going to get u to the 1/2 divided by 2 or divided by 1/2 or multiplied by 2, and I got to go from 225 to 289. So I have 7. Oh, look at how nice this is. Square root of u. 289. So I've got to do 7 square root of 289 minus 7 square root of 225.
17.
What's wrong, Elena?
Why is the 1/2 negative on the top and not negative?
Because I integrated, because I added 1.
Oh, okay.
Okay. All right, square root of 289 is 17 minus 7 times square root of 225. 15. Actually, I'd probably do this, because without a calculator, I'd probably do 7 times 15, 17 minus 50. I factored the 7 out, right? You can do that. Because 7 times 2 is way easier to do. Well, yes, but if you didn't have a calculator, I'm not going to multiply 7 times 17 and 7 times 15. What's wrong?
How do you change the limits?
How do you change the limit? So will you take whatever the number is here and you plug it in for u? Does that make sense?
Yes.
Okay, good.
Hey, how many questions is the test?
I don't know, I haven't written it yet.
Can you make it like 3 questions?
3 questions, all of them really hard.
Oh, no.
Yes. Yes.
No.
And just give us a bunch of points for the work we do.
A bunch of easy ones. All right, let's look at number 8.
I'll fill up like
All
6
right.
pages of work.
Let's talk about this one. This one is an integration by parts, okay? big clue. I've got that natural log in there, right? And if I can't, when I take the derivative of natural log, and I don't get 1 over just that, I know I've got to go by parts, okay? Probably what I would do with this before I try to do my parts, let's see, what did I do there? It looks like I rewrote it a little bit, okay? So, I rewrote, think about it this way. The natural log of m, I'm going to take the 6th and make it a 1/6 out front, and then I'm going to bring that other m upstairs as m cubed to the negative q3 dm. And I know the variable's weird. The test generator throws weird variables in. All right, let's go by parts. So what we've learned by parts is we always do what first? Yeah. That's the natural log of m. So du equals what?
1 over m dm.
1 over m dm.
Oh, I'm so lost with that.
Okay, so all I did here was rewrite this. So the natural log of m stayed, the 1 over 6 came out front, and this m cubed went upstairs by making it negative. And then part says, remember Liate, I have to do natural log first for the u. So the stuff that was left was the dv part is the m to the negative 3 dm. All right, so when I integrate the m to the negative 3, I'm going to add 1. So m to the negative 2 divided by negative 2. All right. We have to be really careful with that 1/6 out in front. I'm going to keep it out in front of the whole thing. Okay? Because look, it looks like it's kept out in front at the end anyways.
Integrate it, you add 1 to the exponent.
Add 1, divide by the new exponent. We okay, Joaquin?
This is the one where I figured out that the first one had a big factor.
Yeah. Okay. So uv, u is the natural log of m. V is this mess right here, right? Could I rewrite that in a different way? I'd probably write it as 1/2 and then bring this downstairs, and it's a negative 1/2, and bring it down as an m squared. And then that was uv minus the v, which is, I'm going to leave it like that this time though. M to the negative 2, I'm going to bring the negative 1/2 out in front, times 1 over m dm. What's wrong?
Are you allowed to change the x?
Sure. Just look at your answers and make sure, if it makes more sense to you with the x's, that's fine. It just make sure that you convert your you know that look in your answers, your m's are going to be x's.
Well, can you do let x let m equal
Sure.
x?
Sure, you can always do that. But remember, it's multiple choice, right? So, all right. This one right here, I'm going to rewrite that before I try to integrate that piece. So, it's really, isn't this really m to the negative 1? Yeah, so I really have m to the negative what? Third dm. And then I still have this 1/6 in front of the whole thing. And I've got a negative 1/2 ln of m over m squared.
Can you explain that again?
Okay, so the only thing I changed was right in here. I can rewrite this 1 over m to m to the negative 1.
Oh, you can.
Yes, right? We're bringing it upstairs, right? Because it's an m to the first, I'm bringing it upstairs. M to the negative 1 times m to the negative 2, we add the exponent, so we get m to the negative 3. All right? All right, so we've got 1/6. I'm keeping this negative 1/2 natural log of m squared, and the 1/2's going to hang out. Okay.
Do 1/2 cancel?
No. Not at this point. Okay? But they're going to factor out in a minute. When I integrate m to the negative 3, remember we have to add 1, so we get m to the negative 2 divided by negative 2 plus c at the end. And remember, this is multiplying here. Even though it looks like a subtraction, it's multiplying. All right, let's see what we can. I'm going to rearrange one more time here. So I've done the integration. I've done the calculus piece. I'm going to say that it's 1/2 m squared on the bottom, natural log of m, plus -1. It's a fourth power, or fourth. It's 2 times -2, and I'm going to bring that m downstairs, plus c.
That's where the factoring is weird.
Yeah, this is where the factoring is weird. Okay. In order to get it to work, because do you see that coefficient of 2 in front of the natural log? See this? Do we have a 2 in front of our natural log right now?
We have a 1.
No, we have a 1, but could I make a common denominator? Yeah, so I'm going to do this in a different color, because I'm going to write over the top. So I can turn this into 2/4. And now I've got a common denominator, and now the 2 appears. Do you see what I could pull out? I can pull out a 1/4 and I'm going to pull the denominator out basically. And an m squared. So we have 1/6 times 1/4 m, or 1/4m squared, and I'm left behind with, I need to pull out a negative.
Yeah.
And then 2 natural log of m plus 1 plus c. From there you could... Excuse me. What's wrong, Alexis?
Why don't you combine the 6 and the 4?
I can. I just was trying to show what I was pulling out.
Oh, I don't know. 4. What is that?
So, -1/6, 1/4m squared, 2 natural log of m plus 1 plus c. And then when you multiply them together, it's this.
Hey, this problem was exhausting.
That one was exhausting. Yes, Elena?
How did you get the 2/4 again?
This here,
Yeah.
I made a common denominator of 4.
Oh.
I knew to do that because looking at this, I wasn't going to get close to any of those answers without a 2 in front. So I had to artificially add a 2 in somehow. I had to manipulate it to get the 2.
Is there gonna be a problem with that?
I don't know.
Please. No.
I haven't decided yet. We'll see.
Don't do it. Don't
All
let me
right.
struggle.
Just to show us.
Okay, how are we doing on time? Oh, we still got time. All right, we ready for the next one? The next one's easy. It looks easy.
Wait, Miss Ballard.
Yes.
It's not. You can't add.
What'd you say yes to?
Denominator, you can't
Yes, I'll
add
have
them
tutoring.
Okay.
What?
Since they have the same denominator, you can't add them both.
You can't add them both?
Yeah.
Look at your answers.
They cost.
I had to factor out to get that answer.
Hey, Miss Ballard, what time?
I don't know yet. That's why I gave you the survey.
I didn't, to be honest, I didn't read the survey.
Yeah.
I told you to do the survey in your email.
My email.
Yes,
Nah, you didn't say that.
It was right on the board.
it was on the board.
Never happened.
See, check school email and answer survey.
Yeah, I answered survey, but the survey got adding you on the 2.
It was office hours. It was in your email, not the one on the website.
Oh.
All right.
No, Mom.
Okay. Are we good with 8 now? Or as good as we're going to be, let's do 9. Okay? All right. Number 9. We have to, let's see, it looks like an integration by parts.
Can you use substitution?
This is 9.
Miss Ballard.
It looks like I've got a typo.
How do I select all the times?
You can't select, just pick the range that works best for you.
5 to 7:15.
From 5 to 7:15, you
After
can
practice, 6 to
pick what
Hey,
what works
We
best.
should have like a summer party at your house.
No. No, that's not going to happen.
6:15.
My house has like movie times in the middle of the night because I have to wake up with the baby. So we get up at like 11 and like 2, like 5, and it's the same show over and over.
What show?
Nurse the baby. Okay. All right, you guys, I think I've got a typo in this one. Did we not get this one to work out? It looks like it should have had a 6 in there. It should have had a 6x in there. Does that change things? Okay. So there, yes, there is going to be a U-Substitution embedded in the whatchamacallit, the Trig or the integration by parts. Does that help? Yeah, there's a typo in there. I'm looking at my notes from last year. All right, so let's try the UDU. So the U would be what, do you think? Liate. So what do I do? It would be the X. There's a flip chart in your notebook. Du equals, this is the pink thing. All right. Du would then be what?
X dx.
It would be just dx. So then my dv is going to be cosine 6x dx. So that's where you need a little u substitution, right? So we're going to do a j substitution. So j is going to be 6x. dj is going to be 6 dx. I have the dx, I don't have the 6. So I got to move it over. So really the only thing I need to add into my integration is a 1/6 in front. When we integrate cosine, what do we get? Sine of 6x.
Hold on. What is the j substitution? Why was that?
It was because we had a 6x function inside of the cosine. So we had to use U-substitution just for that piece. Because remember, I was integrating this, right? Okay. All right, UV, what's your U? X, what's your V? 1/6 sine 6x, good, minus the V, which is still, I should have left more space. So it was 1/6 sine 6x and then dx. Good news, I get to use that j substitution again. Right here, I don't have to redo it. That's nice. So 1/6x, and notice there were limits on there. We're going to deal with that at the end. Okay? Sine 6x minus 1/6. I'm going to talk about that substitution and put it in. So I need to put in j for this, sine of j, and then I have to put in the 1/6 dj. So 1/6 x sine 6x minus 1 what?
12?
1/36.
Whoa,
When we integrate sine, what do we get?
what did you say?
Negative cosine, he added. And then instead of writing j, we're going to write 6x. And we're not doing a plus c because it gave us limits here. So 0 to pi over 6. The double negative becomes positive. All right, we're going to go ahead and plug in pi over 6 first. So we've got 1/6 times pi over 6
Is that pi over 36?
times 6 times pi over 6 plus 1 over 36 cosine of 6 times pi over 6 minus, oh thank goodness, 1/6 times 0 times sine of 6 times 0 is just 0, isn't it?
Yeah.
Minus 1/36 cosine of 0. All right.
One cosine 0 be 1.
Yes, sir.
Yes, that's going to be 1, so this is going to be a negative 1/36 at the back. What's this? This is going to be pi, isn't it?
Yeah.
What's the sign of pi?
3.14.
I was like, wait.
No.
I was joking.
Sign of pi is what?
0.
0, so doesn't that all wipe out right there? So that's gone, so I only have to deal with this.
Wait, is the 1/6 still there? Or that's gone?
No, it's all gone because it's times 0.
That's 6 out.
All right, so 1/36. What's the cosine of pi? Negative 1.
See, this is
All right.
when I do that.
So let's see. Am I on the right track here? So I've got something's wrong. There's a sign mistake somewhere.
Negative 236 is not choice.
It should be negative 236, but I'm not showing that because I've got a double negative here. What happened?
It's
Because cosine of 0 is just 1.
Oh, it should be.
It should just be positive.
This should be positive.
No, because cosine of 0 is 1.
Yeah, it's
so
not
it should
negative
stay
1.
negative.
Oh, it should have
It's
stayed
on the right.
negative.
Yeah.
And then there's one subtraction because you have to subtract the
Oh,
0.
there's already negative 136.
Yeah, it was already negative. Oh wait, it should have been positive there and distributed. Okay, we're good now. So negative 136 and negative 136 is negative 236, which reduces to negative 118.
The answers are already there.
I know, it's the way I downloaded it.
On my test.
I know, it's not going to be like that on your test. It's the way I told it to print. I told it to print with the answers. Yeah.
You know how when the other one you had to plug in one into the U, why didn't you do that?
Because this one was an integration by parts. Let me think about what that other one was. This one, I didn't have to do parts on it. So I went ahead and subbed in the U. I subbed in the U values. I don't have to sub in the U values. I can just leave them off and put this thing back in at the end where we have the U and just use my originals if I wanted to.
It's because that one's in U's, and your limits are for X's.
Yeah. Okay.
That's how I
That's what it really is. Is if you're in U's, you should have U limits. This one here, we use U's, but we never put U's actually into the problem anywhere, right? So I don't have to change the limit. Okay? Alright. What time do we get out? 48. Okay. So I'm going to stop there. We'll see how far. Remember, I also added hints from the book, right? So the multiple choice are technically homework. The hints from the book are not, but I'm going to pull from both for the test. Okay? Likely I will have office hours Monday, but AB also has a test. So likely what I will do is I will give them a part of the time and you part of the time and tell you which part. I'll text out. I'll probably give you guys the later half.
Wait, are you gonna finish with next period?
I don't know. You can tell them that they want to start with number 10.
Because I did not have to do 13 and 14.
How many more do I have to do? 5. Tell them as they come in that they need to start with number 10. Okay.
Why are you laughing?
And you'll record theirs too?
Yeah. I record both. One of the 1 to 4 on. Okay. So, but I will go back and do whatever it is you want to do. All right. So let's look at number 10. All right. So we're going to find the indefinite integral. Let's see where I'm at on this page here. There it is. All right, this one is a lot easier than it looks. Okay. Remember, before we learned integration by parts, we learned U-Substitution, right? So you should kind of think about trying the U-Substitution at least in your head first before you try to do integration by parts. Okay. Especially look at this. I've got two pieces of trig. I've got I know what's the derivative of cosine. So my derivative appears in the problem. U-Substitution is probably going to work out for me. So I'm going to use cosine x as my u, which you just told me that du would be negative sine x dx. So what's the only thing missing? The negative. So the negative isn't a big deal, so I just move that to the other side. If for some reason I had more than just the negative that I had to move, I had a variable I had to move, U-Substitution is not the way to go. Okay, you'd pick something else. All right, so let's try subbing in our u. So for the cosine, what am I putting in? U to the 5th. And then for the sine dx, I am putting in negative du. All right, so we've got to integrate u to the 5th. We get u to the 6 divided by 6 plus c. All right, and I'm putting in cosine x. All right, and let's see. Oh, I've already pre-bubbled the answers for us on this, so we know if we're getting it right or wrong. All right, we good with 10? Yeah? All right, so I'm just going to keep going 11. All right, let's see what we can do with this one. So on this one is a trig one, right, where we've got to separate it. So what are your best guess at separating it into what and what? Well, when it's even, squared and squared, we know what to do with the secant squared, don't we?
Yeah.
So secant squared 5x and secant squared 5x dx. Okay, so now let's think about this. What's the integral of secant squared? Tangent, right? So if I could turn one of these into a tangent, then I've got this part would be part of the du piece. Okay? So let's try turning it into the, it's just the ice falling. All right, let's turn that, let's use a trig identity. So which trig identity do I substitute in for secant squared? 1 plus tangent squared 5x secant squared 5x dx. All right. I am going to go ahead and try to distribute this in. Okay, this time I'm choosing to do that. So I know I have the integral of secant squared 5x, and I'm going to do two separate integrals, plus the integral of tangent squared 5x secant squared 5x dx. Sorry, I'm squishy there. Left too much space. Okay, let's talk about u. All right, look in both of them. What would we use as our u? Well, for this one here, I can't use, I have to do something different in the other one. I apologize. This one here, what am I going to use as my u? 5x. So u is 5x. So du equals 5 dx. So I have 1/5 du is what gets subbed in. Do I really need to put in the du and the u and all that business? I really just need to get the 1/5 in there. So when we integrate secant squared, what do we get? Tangent. Okay, this is a whole different situation because I have to deal with a u for the tangent part of it because I can't integrate tangent squared, but I can integrate tangent. Okay, so I'm going to use a different u. I don't know, let's use j. Okay, so I'm going to call my j tangent of 5x. So the derivative of that is what? Secant squared 5x, and then the chain rule gives us what? 5, and then a dx at the end. So I have the secant squared 5x, I've got the dx, I do not have the 5. So that would have to come to the other side. dj equals secant squared 5x dx. Okay. So, the, what am I going to put in for the tangents? I'm just going to put in what? U, or sorry, j, right? And then for the secant squared 5x dx, we are putting in, sorry, it should be j squared. We're putting in 1/5 dj. So I have 1/5 times the tangent of 5x plus 1/5. When I integrate j squared, what do we get? J cubed over 3 plus c. And then instead of j, I'm going to write down the tangent of 5x. But here's the problem. Look at the answer choices. And sometimes I try to make it so that it doesn't do this, but you guys need to be aware of them. They factor out weird things. Okay? So, what's this denominator right here? 15. What if I tried to make this a 15 as well? Because look at what they're pulling out. Every single one of them has a 1/15 pulled out. So let's try to make this a common denominator of 15. So what would that equivalent fraction be? 3 over 15 tangent of 5x plus, this is just a 15 on the bottom. I'm going to go 1/15 there. Tangent of 5x cubed plus c. It is crazy, I agree. Because we've integrated it at this step right here, right?
I'm gonna need you to go over everything once we're done with this problem.
Okay.
Just to
That's okay. All right. So what do I for sure have to pull out? What does it say? I'm pulling a 1/15 out front. I don't think I need to do a sign flip, so Oh, it does. Look at choice D. I don't need to do a sign flip. I am left behind with, oh, what else could I pull out that's common? I can pull out a tangent 5x. So in this first term, the only thing that's left is 3. In this term, I'm left with a tangent squared 5x plus c, which looks like it's this fourth bubble. All right, I will I don't know if slow or quick, but I will go through it again here in just a second. I'll let you write it down, and then I'll talk about it again. All right, we ready? Okay, so I replaced secant squared with its Pythagorean identity. We cool with that? Everybody good? Yes. Okay, I distributed in secant squared, and I split it into 2 integrals. We okay there? All right. Then I did a U-substitution here. I said my U was going to be 5x, took my derivative. The only thing I really had to add in was the 1/5. So I didn't write down the U, but I did the U-substitution. Okay? I integrate secant squared to tangent. That just stays the way it is until the bottom. Okay? Over here, I had to use tangent to 5x for my U. So the derivative of that was secant squared 5x, and the chain rule gave me 5. Okay, so I had to move the 5 over to make a 1/5 because that was the only thing I didn't have. I have secant squared and dx. Okay, so I substituted in j for the tangent, so it was j squared. And for secant squared 5x dx, I substituted in 1/5 dj. We cool?
Where does the square go on the tangent when you do the U-sub?
When I did the U-sub, the squared stays and it goes right there.
Okay.
Right? I'm subbing in for the function I'm subbing into is the squared.
Okay.
Okay? All right. When we integrate the j squared, I get j cubed over 3. Instead of j, I write down tangent of 5x. The next line, I multiplied these together, I got 15. I had to get a common denominator because I saw in all my answers I had a 1/15 pulled out, so I got a common denominator of 15, which made that 3/15, the 1/5. I pulled out a common, or greatest common factor of 1/15 tangent of 5x, and was left behind with 3 plus tangent squared 5x plus c. Yeah.
Why does the 3 go to squared?
Why does the cubed go to, oh, here?
Yeah.
Because I pulled a greatest common factor, so I pulled one of the tangent of 5x's out front, so I subtracted the exponent. We good?
Oh, it's the same as like it being like tangent cubed 5x. You just move the exponent to the outside.
I moved one of them out because I took out a greatest common factor.
Okay.
Oh yes, this is the same. Instead of writing, I just put it on the inside.
Okay.
It's cleaner that way, and then we know it's on the squared, not on the 5x.
Okay.
All right, we good with 11? All right. So you guys are the lucky ones that get to see all the trig substitution problems. We didn't do any of these last period. All right, so you guys have your little yellow piece of paper out, right? If you don't, you have like 10 seconds to get it out. You need a yellow piece of paper. You're welcome. You will have a copy of that on the test. You do not need to bring your own yellow piece of paper for the test. I make a new copy and give it to you on test day, okay? That way, if there's anything written on it, or you can write as much as you want on it, I'm not going to let you have your notes during the test, right? Okay, so let's talk about 12 here. We're looking at it, when I look at this, all right, I'm going to try the trig substitution on it. I might have been able to get away with a U, I don't know, okay, but I'm going to try the trig on it. So, in the original instructions, it said to do trig substitution. Okay, that's probably why I did the trig substitution on it. I took that out of the instructions because I want you to start recognizing when to do trig sub and when not to. Okay. All right. So on this here, what would your... Actually, I'm going to rewrite it a little bit. I'm going to rewrite it as x over the square root of 81 minus x squared cubed. Probably because of the cubed on there, the trig substitution probably works better than trying to do a U-sub or trying to, and it's definitely not one of the arc integrals, right? I'd try to do that before I did trig sub. All right, so your number is always your a, your u is always your x, right? So what would we use for a in this case? 9. And what would you use for x? Sorry, for u. x. All right, so we're looking at the row. So let's see, I've got a number minus a variable. So which one is it? Which row am I looking at? The first row. So I'm going to draw my first row triangle. All right, so I've got theta. All right, and then let's see. What goes on the hypotenuse for that triangle? 9. What goes on the opposite leg? X. And so that means the radical mess has to go here, right? So, and I'm just putting the radical, I'm not putting the cubed. All right, and I lost my dx. We got to keep the dx in there. That's important for these. All right, I'm going to go ahead and do my extra work, the little extra lines underneath here because I'm out of space. So the u equation equals what? What's your a? 9 sine u and this, or sine theta, right? So that means we have to take a derivative of it. So du equals what? 9 cosine theta d theta. Then I put my squiggle and we do our radical equation. All right. What do I put for our radical equation in this one? 9 cosine theta. Now we're going to use that to substitute into this thing. So for the radical, what are we substituting in? 9 cosine theta, and I have to cube that whole thing. For the x, what are we substituting in? What happened? This should have been an x, not a u, huh? Sorry. All right, so for the x, I'm putting in 9 sine theta. Are we okay? What's wrong, Greg? The u's. Oh, that, okay. You got to stop me faster. It's okay. If you have to stop me in the middle, it's fine. All right, dx is going to be what? 9 cosine theta d theta. All right, before I'm going to deal with this cubed mess here. I could have probably cubed it there, but what's 9 cubed? Or actually, do this. Check this out. We don't need to know what 9 cubed is. Can't I write it like that? 9 sine theta, 9 cos. Why did I do that? We know that all that junk cancels, right? Why do we really need to multiply it out? So we got 9, 9, 9, 9 all gone. What else can I cancel? Cosine with one of those, that's going to become a 2. So I'm going to clean it up a little bit. Let me see how I cleaned it up. All right. And I'm going to rearrange things at the same time because I don't want to write too many more steps. I know there's a 1/9. I also know I've got a cosine, sorry, not a cosine, sine, right, on the top. I've got a sine theta, and I'm going to use my trig to my advantage and write the trig the way I'd like to see it. So sine theta over cosine theta times 1 over cosine theta d theta. Why did I write it like that? Do we know what sine over cosine is? Do we know what 1 over cosine is? Okay, so let's write that out. So what is sine over cosine? Tangent. I'm going to write it in the back. Okay. Tangent theta. What's 1 over cosine? Secant theta. So why did I reverse the order? What does that integrate to? Secant. Did I really need to reverse the order? I know that it doesn't matter if it's secant theta, tangent theta, or tangent theta, secant theta. It still integrates to secant. But we know the integral in the order of secant tangent. All right, am I done yet? I don't have one of those answers, so I'm not done yet. I have to go back to reference my triangle and find the secant of it, and don't forget the SOHCAHTOA sign in the front of the room, right? So secant is in the middle of the bottom one. So hypotenuse over adjacent. What's your hypotenuse? 9. So we've got 9 over the adjacent is the radical, right? 81 minus x squared plus c. Am I done yet? No, we got to cancel the 9s. So we get 1 over the square root of 81 minus x squared plus c. Is that one there? It's A. Or the first one, the first bubble. All right, we doing okay on that one? keep going. 2 more trig subs. Okay, so looking at what we have there, let's first of all, let's identify A and U. That's kind of what we had learned to do. So what's our A? 2, and what's the U? X. I have a number plus a variable. So on my yellow sheet, a number plus a variable is what? Tangent. So I know I've got to use the tangent row of my chart. All right. So what goes on the hypotenuse in the tangent row? The radical. All right. What goes on the opposite leg? X. Good. What goes on the adjacent leg? 2. Perfect. All right. Again, I'm going to write my work underneath here. So we know that X equals, not U this time, X equals, you're using your U equation. What do we write? 2 tangent theta. So then I have to take the derivative of that, and I get what? Good. 2 secant squared theta d theta. All right, then I need to write my radical equation, which was 4 plus x squared. What's my radical equation supposed to be? 2 secant theta. All right, let's try this. Let's try subbing in now. So for the x, what am I going to put in? 2 tangent theta. For the radical, what do I put in? 2 secant theta, and then for the dx, what do we put in? 2 secant squared theta d theta. Okay. What can I pull out front? I can pull a 2 out, or no, not just a 2, but what can I pull out front? An 8. We're multiplying, so we don't have a greatest common factor. We're pulling that 8 out in front. It looks like I am going to leave it. Okay, we're going to do a U-substitution from here. So I'm going to leave it as secant theta. I'm just rearranging tangent theta, secant squared theta d theta. Let me change colors. Okay. If I used secant as my U, or let's say it's J, okay? So J is secant theta. What's dJ then? Secant theta, tangent theta. Do we see it in there? See how we have that piece in there? I knew just looking at it, I couldn't integrate it the way it was with the secant cubed. I'd have to break something off. So I'm using my U, or in this case, J substitution. So what's going to go in for the secant that's underlined? J. What's going to go in for the secant theta, tangent theta, d theta? dj. Isn't that nicer to integrate? Okay, so 8. I lost a squared. Yeah. All right. When I integrate the squared, what do we get?
2.
Cubed over 3 plus c. What's going to go in here instead of j? Secant theta. And then I have to go to the triangle. I've got 8/3. I'm cubing whatever goes in there. All right, secant is hypotenuse over adjacent. What's my hypotenuse? The square root of 4 plus x squared. And what's the adjacent? 2. Okay, I want you to think about this now, because I don't want to have to write a ton of more work, because I know it's exhausting right now. What's 2 cubed? Doesn't that go? Right, because it's really 2 cubed. So I really have the square root of 4 plus x squared cubed over 3 plus c. Isn't that the same as this? To the 3/2 power. I could have rewritten it as 3/2 power.
Wait, how did you cancel
2 cubed is 8.
Oh.
Right? I know it doesn't look like that. I could have rewritten my cubed on both of them, right? That might help. All right, we good with 13? Not yet? Okay. All right, we good to go, ready to go to 14? Okay. So, I'm going to rewrite it. 1 over the square root of x squared plus 8 cubed dx. Okay, what are you going to use as your u, and what are we going to, what's our a? Radical 8, and I'm not worried about doing, like, simplifying that radical. We're going to leave it radical 8. Okay, what is your u going to be? Good. So I've got a number plus, sorry, a variable plus a number. So what's a variable plus a number? Which row? It's the second row again, right? Tangent. Okay, so theta, what goes on the hypotenuse? The radical. So x squared plus 8, what goes on the opposite leg? X, and what goes on the adjacent leg? Radical 8. Good. All right, so our u equation, which is going to be x equals what? Square root of 8 tangent theta. So dx ends up equaling what? Secant squared theta d theta. All right, and then our radical equation equals what? Radical 8 secant theta. And I know it looks scary to have all these radicals in there. All right, let's sub in. So let's see, for the radical, what are we subbing in? Radical 8 secant theta. Now let's think about this. How many of these do I really have? 3. So couldn't I just write it 3 times rather than trying to cube it? Just bear with me. It's a technique, right? So I wrote it 3 times because it told us there were 3 of them. All right. For the only thing I have other than that is the dx. What's the dx? Radical 8 secant squared theta d theta. Okay, what can I do? Take out a radical 8. What else? 2 secants, because there's a secant squared. All right, let's see what we have left. What's square root of 8 times square root of 8? 8. So don't I have a 1/8 I can pull out front? That made the radical go away. Wasn't that nice? Look at all the answers. Don't they all have an 8 in them? No radical, just an 8. All right, and then we've got 1 over secant theta left behind. What's 1 over secant? Cosine theta d theta. That's much better. When we integrate cosine, what do we get? Positive sine theta plus c. And now we're going to go back to our triangle. In our triangle, we need the opposite over the hypotenuse. What's your opposite? X, and your hypotenuse? Radical x squared plus 8. So it's definitely looking like this first one. Okay, now that we've done all of them, okay, that we're done the last part of them, so now between you guys and